Good morning, everyone. Thank you for joining this session. So, in this session, we will discuss about our last example last week. Okay, so I believe I asked you to work on it by yourself. Yeah, so in this session, we will discuss about the results. And then after I finish explaining, yeah, I will give you one assignment, for you to practice on mass balance with and without reaction. Okay, so it is actually to prepare you for the upcoming quiz, on Wednesday. Okay, you may access your Edlink account, to see the problems of the second assignment. Yeah, please work on it, okay, by today. Yeah, because the submission will due today at 5 p.m. in the evening. Yeah, please submit it in the form of paper worksheet. Yeah, and you can submit it directly to my locker in the administrative office. Okay, at 5 p.m. sharp. Okay. Okay, so without further ado, I will start explaining the last assignment I gave last week. Okay. Okay, so as you can see in my screen, there are two PDF files. Okay, so the first file on the left is the problem, while the answer is on the right-hand side. Okay, so in this problem, we have a small power station that burns fuel oil in the boiler furnace. Okay, so they say, that 15% excess air is the accepted minimum value for satisfactory combustion. Okay, and then we are asked, to determine whether sufficient air is being supplied to the furnace based on the results, based on the analysis. So this analysis provides a result like this, provide a composition data like this. Okay, so based on this composition data, we are asked to calculate the percentage of excess air that is currently being used. Okay. So if it's less than 15%, then of course the combustion will not be satisfactory. However, if it's higher than 15%, then it would be, there will be a profit loss, right? Okay, so after we determine the percentage of excess air, then we are asked to determine what is the action that we should do. Should we reduce the amount of excess air or should we increase the amount of excess air? Okay, so I will copy the data of the flue gas, okay, to the block diagram. Okay, so it's dry basis by volume. Okay, so this is a volume percentage, so I will copy it here. And since it's dry basis, so we cannot say that there is no water. There will be water. Why? Because fuel oil is actually hydrocarbon. And when we burn hydrocarbon, there will be water as a product. So even though in this problem, in this compositional data, there is no water in it. However, there will be water. Why there is no water? Because the analysis is on a dry basis. Okay? Okay, so I will copy first, okay? I will copy this. Okay? Okay. Yeah. Okay, I will enlarge the second file. Okay. Yeah, so we have the fuel oil, okay? In the form of hydrocarbon, but we don't know what kind of hydrocarbon that is. Yeah, so we will assume it as CXHY. Okay, and then there is an air coming in. Yeah, of course. Why? Because there is carbon dioxide and carbon monoxide produced. Yeah, so there is a combustion. Yeah, and hydrocarbon cannot burn itself. Yeah, there should be an oxygen there. Okay. Yeah, and they also mention it in the problem that there is air there. Yeah, but whether it's sufficient or not, that's what we are going to find. Okay, so we put excess air with this composition. Okay, and then there is a product. Okay, now the product, I use the compositional data. Okay, so we have 82% N2, 3% O2, 2.5% CO2, and 12.5% of 2.5 CO and then 12.5% CO2. Okay, so I would do a basis 100 moles of, okay, sorry, this is not output, but output minus water. Okay, so this is 100 moles actually only refer to the four components. Yeah, without water. However, is there any water? Yes. Yeah, but for the basis, I will use 100 moles total of these four components. Okay, so using the percentage and this total moles, then I can actually get the moles of every component. Okay, without the air, without the water, of course. Yeah. Okay. Okay, so N2 is 82 mole, O2 3 moles, CO 2.5 moles, CO2 12.5 moles. Okay. Okay. Oh, we see there are two types of carbon oxides. Yeah, we have carbon monoxide and carbon dioxide. So there will be two reactions, the complete one and the incomplete one. Okay, so I will write down all the chemical equations. Okay, and then don't forget to balance every elements, yeah, on both sides. Okay, for the two reactions. Okay, okay, and then based from what I know from the products, oh, I know that I have 2.5 moles of carbon monoxide in the output, and then 12.5 moles of carbon dioxide in the output. Okay, so I will put the numbers here, 12.5 for carbon dioxide and 2.5 for carbon monoxide. Okay, I'm so sorry, I have to check. C H Y. Oh, I made a mistake here. Wait, let me recheck. Yeah. Oh, X over 2, Y over 4. Oh, yeah. So this one is for the incomplete combustion. So there is no 2 here. Okay. This one is CO2. This one is CO. Yeah. The coefficient in front of the O2 are correct. Okay. For both reactions. Okay. So this one is CO, this one is CO2. Okay, so that's why I put 2.5 here for CO and then 12.5 here for CO2. Okay, and then, yeah, by calculating, yeah, using the coefficient, yeah, in front of each components, then I can actually find the mole, yeah, that is actually used, yeah, the mole of oxygen that is actually used in the furnace. Okay, and then I can also find the initial mole of the fuel oil. Why I can say it's the initial mole of hydrocarbon? Yeah, because as you can see here, there is no hydrocarbon left in the product. Yeah, so I believe that all are burned, yeah, into CO2 and CO. Okay, so I can say this actually equals, the total of this is actually equals to the total moles of the fuel oil. Yeah, the initial one, I mean. Okay. Okay, so after I finish with the two reactions, yeah, I will go with the nitrogen. Why nitrogen is important? Because I cannot see nitrogen here. I can see nitrogen here in the inlet. Okay, so the nitrogen here and nitrogen here will be the same, right? Yeah, because it's inert. Okay, so the N2 in equals to N2 out equals to 82 moles. And it equals to 0.79 A. Yeah, because for air, it consists of 79% of nitrogen and 21% of oxygen. Okay, so finally, using this equation, I can find the number of mole of A. Okay, and of course, I can find the number of mole of the oxygen in. Okay, so I know the inlet oxygen and I know the outlet oxygen. Okay, so actually I can find the number of moles of oxygen that reacts. Yeah. Okay, so this. So this is the actual oxygen that is used, yeah, in the furnace. Okay? Now, okay, and then from these two chemical reaction, you know the number of oxygen, the mole number of oxygen that is actually used, yeah, inside the furnace, right? In the form of X and Y. Okay? And this one is in the form of number. So actually, I can put this into one equation like this. Yeah. So this one plus this one equal to this one. Okay. And then using the simple mathematical equation, calculation, then we can find y over x. Yeah. You can also change it to x over y. Yeah. Depends on what you need later. Okay. Okay, so I will stay with my y over x equals to 1.346. Okay, now, and then the next step, yeah, I will go with the theoretical error. Yeah, because when I want to calculate the excess error, yeah, I have to know the theoretical error. Okay, and theoretical error is actually defined, yeah, or calculated based on the complete combustion of the total input of the organic components, yeah, or the carbon-based components. Okay, okay. So delta CX Y, okay, plus O2 all becomes CO2 because for me to calculate the theoretical error, I have to assume that everything converted to CO2. Okay, and then water, of course, yeah. And then again, theoretical error is calculated based on the complete combustion of the total input of the carbon-based components. Okay, and then we know from the two reactions above that the total mole of the fuel oil is this. Yeah, I will scroll it up. Okay, 12.5 over x and 2.5 over x. Okay, so it's 15 over x. Okay, this is the total input of fuel oil. Okay, and then using the comparison, yeah, of the what is it? Of the coefficient, yeah, I can actually find the theoretical oxygen, yeah, which is 15 over x times x plus y over 2. Okay, so this is the theoretical error. Sorry, the theoretical oxygen. Okay. Oh, I know the y over x from the previous calculation. So I substitute the number inside the equation. Then I can get the theoretical oxygen should be 25.095 mole. Okay. Okay. And then back to the question. Yeah, I will click. Sorry. I will enlarge this part. By calculating the percentage excess air that is currently being used, we are asked to determine what kind of action we should take, right? Okay, so I will go back. Yeah, I have to calculate the excess air. Yeah, okay, so based on the calculation before, we know that the input oxygen, yeah, is 21.8 mole, right? Okay, and then the theoretical is 25.1 mole. Okay, so I will use the equation, yeah, of XSR, input minus theoretical over theoretical times 100%, and we can get the percentage of XSR. So I put all of them inside, and I can get that the actual error is definitely insufficient. Yeah, why? Because when you put this, it becomes minus. So it's not excess. Yeah. Yeah, it doesn't even reach the theoretical one. Okay? Okay. So it's minus. Yeah. Okay. Okay. So the action that we should take is to add air until 15% excess. Yeah. So we have to add some more. Yeah. Oxygen. Yeah. To the furnace chamber. Okay. Which is 33.6274 moles of air, or we need to add this number of oxygen. Yeah. Okay, how we calculate this? I use this. Yeah, so I use this equation equals to 15%, right? And then this is the theoretical. So I can get that actually the input oxygen, yeah, that should be supplied to the furnace is 28.8593 moles. Yeah. While we only provide 21. So we should add another 7 moles of oxygen, or we should add this. Yeah, 33.6 moles of air. We should add that much air. Okay? Okay, so if you have any question, you may actually chat, drop a message to my WhatsApp number. Yeah, you can ask. Yeah, or maybe you can just knock my door, and then ask me directly. Okay? Okay, I think that's all for today's session. Yeah. Don't forget, there is an assignment posted in at link. So please do access your account and then download the file and then please work on it on a paper. Okay, submit it directly to my locker in the administrative office by 5 p.m. today. Okay, thank you very much, and I will see you again on Wednesday. Okay, for the quiz. Okay, thank you very much.